Last class, we were talking about the chemical reaction. Problem that involved chemical reaction. And we said that the difference between the physical and the chemical problem, the main difference is the term generation and consumption. They will be no longer same. Then I said there are some very important definitions that you have to know. We talk about the stoichiometric coefficient, stoichiometric ratio, and limiting reactant or excess. And I will stop here now. When I was talking about the limiting reactant, now we said it is the one that will, it's determining step, right? The one that will finish first. And then it does not mean that in reality the reaction goes to completion. No. It is the limiting. I decide about the limiting assuming that the reaction goes to completion. What if the reaction didn't go to completion? Is there a limiting? Yes, still there is a limiting. The limiting is the one that will finish if the reaction goes to completion. Then we talk about the fractional excess. So if I have one limiting معناته الثاني شنو؟ in excess. شلون نحسب fractional excess؟ شلون نحسب fractional excess؟ You know we have equation that's we compare n in the feed, which is the actual n that we put, minus the amount of n from the stoichiometric. What does it mean? The amount that you need when the reaction goes to completion, divided by the n stock. Okay? Other definition, fractional conversion. أرجع أقول شباب I'm going slowly here because those definitions, if you don't understand them or if you misunderstand them, you will solve the problem. Because they will be either given to you or you will be asking or you will be asked to calculate. واضحة؟ Fractional conversion. Usually the chemical reaction, for practical reason, does not go to completion. Why? Always the reaction takes place instantaneously. What do I mean by that? أرجع وأقول if you have a reaction, you will see that at the beginning it goes slowly, then with time start to become slow because the amount of the reactant that you have decreases. So the rate of conversion will decrease. What are we gonna see? And sometimes you will see that in first 30 minutes 90% conversion. In 30 minutes, 90% conversion. No, I need more. There is no problem. So, if you continue, you will find yourself maybe after 1 hour, which is 60 minutes, you get 98%, for example. Now think about it. Think about it. If in the first 30 minutes you achieve 90%, does it worth it to wait another 30 minutes to get extra 8%? لاحظ هنا I'm talking about conversion. I'm not talking about purity. I'm not talking about anything else. I'm talking about conversion. What does conversion mean? Conversion means that if you start with 100 mole A, which is you have A plus B going to C plus D, for example. If you start with 100 mole of A, you need what? You need all the 100 to be reacted, right?
Yes.
Because if 100 mole of A reacted, it will give you 100 mole of C. If C is my desired product, which is good. But now, in the first 30 minutes, I get 90% conversion. يعني after 30 minutes, 90 mole of A has been converted. بقى 10. If I want to wait for this 10 to finish, it will take forever. طبعا time is energy, right? Because you are running the reactor. So you need to put money. Does it worth or no? Sometimes you look لا والله. After 30 minutes, you have 90%. The 10% that did not react, take it and recycle. So no need to wait. So that's why usually when they design the reactor, they don't design it for 100% conversion because it will take long time. واضح شباب? Accordingly, an amount of the reactant will be left in the reactor with the reaction product. طيب, how can we calculate the fractional conversion of a reactant? Fractional conversion of the reactant, they call it F equal moles reacted divided by moles filled with percent conversion equal 100 times. واضح يا شباب؟ So ارجع واقول now if he is telling you in the question that 90% conversion وسكت, in a problem now sometimes you have A plus B equals C plus D, and I'm telling you that 90% conversion from A or from B. This is the most important thing. يستاهل. No, really, because if it is not given, you have to do it for the limiting reactant. If it's not given. But what if A is the limiting reactant وقال لي 90% conversion of B? كيف؟ هو قال لي 90% conversion of B. So in that case, I don't have to go and calculate which one is the limiting reactant because it is given to me, it is 90% conversion of one. If it's not given, no, I have to calculate first which one is the limiting reactant. واضح شباب؟ Any question? طيب خلينا ناخذ example وبعدين I will talk about how can we solve any chemical problem. Suppose you started with 5 moles H2 20 moles N2 and 2 moles of NH3. Okay? And the equation that you have 3H2 plus N2 give me 2 NH3. Production of ammonia. And I start with these amounts. I have, from the beginning, I have also some ammonia in that reactor remaining from a batch before that. There is no problem. If he is telling you that you have some of the product from the beginning, it's okay. After certain time, what happened? 2 moles of H2 has reacted. Okay? So, how many moles of each species will be present at this? واضح السؤال؟ Very easy. What do I have? At the beginning I have 5 mole H2, 20 moles N2, 2 moles ammonia. After certain time, 2 moles of H2 reacted. بعد نص ساعة 2 moles of H2 reacted. At that time, suppose that I stop the reaction. What are you gonna have in that reactor if you open it? كم NH2 بيكون عندي at that time?
3 moles.
كيف حسبتها؟
5 minus 2.
We have 5 minus 2 طلع 3 moles. This is very easy. Because he's telling me that 2 moles has been reacted. What about amount of N2? Now it starts with 20. Will it be increasing or decreasing? Decreasing because it will react. صح؟ لازم أعرف الآن أنا how many mole has been reacted from the 20. So to calculate moles of N2 reacted. When or 3 moles H2 needs 1 mole N2. مظبوط؟ وش احنا نتأكد هذه موزونة ولا لا؟ 6 6 2 2. So 3 moles need 2 moles. How many moles reacted? 2 moles. H2 it needs X mole and 2. Then X will equal 2 over 3 moles. شنو هذه 2 over 3? Number of mole of N2 that has been reacted. So N2 will equal 20 minus 2/3 صح؟ يعني ايش بيطلع؟ 19 moles. هذا اللي بيطلع. هذا اللي بيطلع. Now, what about the NH3? NH3, we had 2 moles at the beginning. What happened after this time? Increase or decrease?
Increase.
It is a product, right?
Yes.
So it will increase. So we have to add to it amount of NH3 that has been produced from the 3 mole of H2. Again, 3 moles. H2 will give me 2 moles
NH3.
and H3. Then 2 moles. H2 will give me X mole and H3. Then X will equal 4/3. مظبوط؟ 4/3 يعني 1/3. إذا N H3 will equal كم كان عندي؟ 2 plus 4/3 يعني 3/3 equal 7/3. مظبوطة يا شباب؟ مظبوطة؟ ليش؟
10
ليش؟
10 over 3.
صح. لأن هذه شو بتكون؟ 6 على 3 which is 3 and a third. 3 and a third. Is there something will show me يعني زي ما نقول general equation that will give me this? Yes. In general if zeta mole of H2 reacted, then N H2 will equal N H2 0 minus zeta. N2 will equal N2 0 minus 1/3 zeta. And NH3 equal NH3 0 plus 2/3 zeta. من وين احنا جبنا هالزيتا هذول؟
من برج reactive noise.
هذا المعادلة مرة ثانية. نتذكر شنو المعادلة؟ كانت 3 H2 plus
N2
N2 give me 2
NH3.
and H3. Okay?
Yes.
And here I am basing on zeta of H2. So I have to divide by 3. So H2 plus 1/3 N2 give me 2/3 and H3. إذن لاحظ شيء. The coefficient of zeta is what? Is the stoichiometry in the equation. If it is reactant, we put minus. Because with time the amount decrease. If it's a reactant, we put a minus because the amount is decreased. If it is a product, it is a plus because the amount is increased. واضح يا شباب؟ This is we need it في الميثود اللي we will use it later. They call it extent of reaction. Very important if we have equilibrium, and we can also use it for any reactor. Around any reactor we can do extent of reaction balance. هذا يسموه extent of reaction balance. So if we know how much H2 or N2 are consumed, or how much NH3 is formed, we can determine zeta, which is they call it extent of reaction. So in general, Ni equal Ni 0 plus okay? So
بس قانون زيت الكما او وش معناها؟
كيف؟
الكما او وش معناها؟ NH2 كما او.
Initial at time 0. This is always at time 0. At time 0. طيب شنو الفي اي؟ في اي is the stoichiometric
coefficient.
coefficient of species 5. It is minus 4 reactant and plus 4
Product.
Later you will discover one thing, or I will give you one thing. In order to solve any problem using the extent of reaction, you need information from the output. You will see that you need information from the output. So if you have one zeta, you need one information. If you have two zeta, you need two information. How can we get this information? From the thing that we are talking about, fractional convergence, fractional excess. Then later we will talk also about the selectivity and the yield. So you have four things. ولو شيء زيادة ولا So fractional convergence, fractional excess, yield, and selectivity. Please, always remember those. Always you will need them to solve. Either they will ask you to do it, or they will give it to you, so you have to use it in order to solve the problem. Especially if you have more than one reaction. نتكلم احنا selectivity والyield لما يكون عندك more than one reaction.
More than one zeta, that mean more than one reaction.
Yes, each reaction has its own zeta. If you have 5 reactions, you have 5 different zeta.
This one.
كل يعني هذه خاصية إلى التفاعل، الزيادة هي خاصية إلى التفاعل. واضح شباب؟
Okay.
Any question؟ طيب